Alright, so I had taken this guy apart to see if I could replicate it, just to sort of see if I got super lucky. And I kind of did, I guess you could say, because I had to go through a fairly extensive learning process again to really hone down how to replicate that just right. But the way I had described it first was pretty much dead on. Upon making this, I realized that it was pretty much imperative with this setup that the coil be low enough. I couldn't have the coil sitting at surface level with these magnets. Now the distance on that, I actually want to say, isn't quite as much as it was with this little one. For whatever reason, I was able to get a little bit more distance on that. But playing this, I realized there was actually quite a few different configurations where this would work, as far as just getting it to hover. But there was only one configuration, which is where it's at now, where I could get it to actually work all the way down when I cut my power supply below what it'll actually read. So it's about a volt now. So just like that one before would run at a volt, I'm able to get this one to run at that volt also. And the benefit of that for me is, if I actually do use an aluminum surface, a very thin aluminum sheet, just to sort of help stabilize it, I won't have to hear that crazy pulsing going on, which is just due to a certain amount of current that's going in there. Once you drop that current down to a certain point, the amplitude, you just can't hear it anymore. But before I made that one, I tried this guy out. And if you notice the difference, the magnets are just about, they're a little bit wider, a little bit further apart than on this one. But they're also right below the surface level. If you see this one, the coil here is almost flush with the surface. So you could say the coil is just about flush with the magnets here. And the only way that would work is if I used the air coil. So I took the core out of here, got the sensor just kind of dug down in there. But this one works as well. It's not quite, it won't quite get as stable as that one can. I haven't quite tuned this one either, but you know, obviously with the aluminum it helps. But I noticed here, because I'm using this, basically this huge aluminum speaker, essentially is what it turns into, then I can hear it, the oscillation much more, and I had to slightly skew some of these magnets here, using this hot glue catastrophe just to get it the alignment right so it'll sit straight. So here's the other one. You can hear how loud it is. This one, at least so far, I have to use some type of aluminum to slow it down with lens. Otherwise, it goes bonkers. But that could be due to a few factors, but you can kind of hear when that thing works. That's pretty much what's going on when you play with these, except this one just gives you audible feedback. But yeah, able to tweak this one around a little bit, so that'll run down from a volt or less too, so I don't have to deal with that noise. I can still barely hear it, but you know, it's not, it's just sitting in this roll of duct tape right now, so whatever. So hard to get it perfect. It's not gonna be perfect. It sits well enough though, I think. Yeah, this was a interesting dynamic. So yeah, this is another one that was it's pulling on it with the air coil. Cool thing about this setup is, if you were to actually use this arrangement with higher power and a bigger coil, then the easy thing to do is just build this arrangement. But instead of using a core, which might even work as well, but I would stick with the air core. Just put a tiny little piece of metal right there. So I was able to do that also. I used a little curl of a spring also, put that down there, but you're just looking for something around that point to keep this bottom end sort of centered. And that's it. That helps with the stability. But this kind of worked out where I didn't really need it. I mean, it obviously helps, but yeah. And I'm just using the aluminum sheet, obviously, still. Capacitor rundown to get a better idea of the draw. But I charged this one a little over 1.5 volts. It's looking like the rundown is significantly quicker than on this little guy right here. Now that is a 100 farad supercapacitor, so that's no small cap. But I feel like it'll give me maybe a little better idea of what's going on as far as the power draw. So I'd imagine once it gets down closer to a volt, it's hard to say. But that does look like it's dropping much quicker. So this one right here is the very first one I made that was running from the Arduino. And I wanted to see if I could run it from just a transistor like some of these other circuits we're using that I actually wasn't aware of till I started using the Arduino. But so I had a one tip 120 laying around. I had a couple random MOSFETs. I think this one was a IR640N, which is right around sort of what would have worked. Then I was thinking about if I couldn't get that to switch, then just use a small transistor to do that. And then I started thinking, like, man, that's got to be incredibly difficult to get the alignment just right. I mean, you've got to get the transistor to cut on or off at just the right time. And the problem there is I've got nothing but linear Hall sensors. So playing with this one, I noticed that the good thing about these sensors I have is they're the kind that will reference a positive or negative voltage. So I guess you could say they're bipolar, but depending on the polarity of the magnet, when you bring it close to the sensor, it's either going to drop that 2.5 or so volts up closer to 5 or down closer to 0. And it just so happens, I noticed that with this tip 120, it worked out just right where I can put the sensor right about where it's at. There's a very slight gap in between the coil, and configure it so that, or turn the polarity just right, get everything just right as far as the coil, the magnet. So when I bring it close to the sensor, it shuts the transistor off, which is basically what you're looking for in this type of scenario. You want it to constantly be pulling it. Then when it gets close enough, it shuts off. So it just so happened to work out for me where right around there is when it drops that voltage in the sensor, feeding the base of that transistor just enough where it cuts off. And I want to say I kind of got lucky there, but not quite, because right now, as you can see, I'm cheating. I'm using a piece of aluminum right there to help keep it steady. Because without that, it will eventually rattle and fall, which is a common issue here. Now, I would imagine to fix that problem is going to take quite a bit of adjustment, which, to be honest, I'm not real keen on doing at the moment. So I'm thinking about just rigging a way to use Lenz's law to keep it stable in this type of simple situation. Now, having said that, there's got to be a way, since you're able to reference a positive and negative voltage with that sensor, there's got to be a way to use a comparator or something to get that to form some type of feedback loop there, so you can actually use that maybe with some other chip to get that to stabilize. and I'm actually able to hold a few different types of magnets on there. The amount of weight that it will support is pretty good. It's just, depending on the weight I put on it, certain weights are going to be more stable than others. This one is what the Arduino is using right now, and that's still running off that AA. And it's probably drained down pretty good by now. So yeah, we're about 1.2. It's actually still hasn't gone under 1.2 yet, and it's been running quite some time. So one of my goals was to try to use this type of arrangement with the simple transistor switching circuit, and I'm wondering if that's just going to be too difficult with the tolerances that I've got in this type of deal. Only problem there is I've already glued everything down. I don't really have a lot of leeway as far as changing the variables as far as the magnets and the coil and the sensor. So it would just be sheer luck if I'd be able to get that to work. That's pretty much what happened with this one. The sensor was the only thing I really played with. Now, where Slider, I noticed, had a really genius way of using a core to tune, or a tuning rod in there to very slightly make adjustments. I'm wondering if there's another way to do that, maybe as far as just putting a trimmer on that sensor. Maybe like a 500, like a 1K trimmer or something. And I'm wondering if maybe that would work as sort of an on-the-fly way to vary the biasing of that, or the switching of that base on the transistor. I'm not really sure, but I thought that was pretty cool. I didn't actually expect that to work like it would. Now, I need to put some type of LED on there. That would probably help. But yeah, so basically literally just a tip 120. That's two 2Ks on there to form 1K resistance across the base, directly to the output of the sensor, and that's it. It really is about as simple as it can get right there. Yeah, cool beans. This little guy, I don't think that circuit is going to work out for that. This is going to need something different. Just the way this is, it's got a slight push at the end. Yeah, I don't know. That one, I would have better chance in theory, but like I say, the tolerance is just crazy low. But after that one, after that little guy, and then this other one that I had made immediately after that one, I'd say I'm about good on the little ones. It's about time to move on to larger ones, but I do think these little ones are pretty cool. They got some practical value.